Timers are widely used in PLCs in automation tasks to delay signals. They are defined in the official standard for PLC programming languages, IEC 61131-3. In this video, we will see what the different types of timers are and how to implement them in TwinCAT. The first of the three timers we will be looking at is the T-on timer. Simply put, it allows an output to be turned on after a delay. Next one is the T-off timer. This allows an output to be turned off after a delay. And lastly, there is a TP or pulse timer. This generates a pulse of specific length. The timers need a Boolean input to trigger them, and the timer's output, which is also Boolean, is used in the logic. They also need an input to define the timer period. Let's explore them one by one and see how to implement them in TwinCAT. The timers defined in IEC 61131-3 are function blocks, and in order to use them, they have to be instantiated with a unique instance name. Here's our application scenario. Imagine we have a proximity sensor which causes a pneumatic brake to come on when it detects an object. However, we want the brake to engage 3 seconds after the object is picked up by the sensor. So we want to delay the brake engagement from the time the sensor is picked up. So for this application, we will need to use the on delay timer, which is our T on timer in TwinCAT. Let's see how this works in ladder logic first. So we're going to hop on to TwinCAT. I have already created a training program here. And this is our main program, which runs all the time. And we are going to create another program in ladder. We will call it LD1, and implementation is in ladder logic. So either we can use the tools from the toolbar menu, or so we will call it T-on brake delay timer. Now the auto declare box pops up, and it shows our name, the type, and if you want to add any comments, you can say 3-second delay for brake engagement. So if you go back to the parent program, which is the main, we can see the declaration here. We will also need to declare its inputs and outputs. So the input would be the proximity sensor. Let's call it B prox sensor of type bool. And the output would be the brake, which would be a solenoid, a cylinder, any type of output. B brake output, also of type bool. There, our timer and the booleans are declared. Let's go back to our ladder program. As you can see, the timer has 2 inputs and 2 outputs. Input is the boolean, which starts the timer on the rising edge of the input. PT is the time to pass before the output is set. So here is our B prox sensor, and we want a 3-second delay before the brake gets engaged. So here we will declare the 3 seconds. So the format is T hash 3 seconds. On the output, we'll set a coil for the brake. This output is the elapsed time, so it shows you in real time as the timer is running. We don't have any use for this just yet, so we will just clear this out. And there, our function is implemented. In order to see this in action, I will set up a scope project. So let's go to the data pool. Here are our two booleans. We'll add them to the data pool. And let's create a YT chart. Let's add these here. Just for clarity, let's make the lines thicker. And we will place the scope project just underneath our PLC project. So we'll say call break engagement program. Put it into run mode. Go to the program and let's try this again. Proximity sensor comes on. 3 seconds later, the output comes on. Now, when you turn off the input to the timer, the output drops immediately. So this is how the T-on timer works. Let's see the implementation in statement logic. So we will use the same declarations and comment out the ladder program. We will add statement logics. Let's call it ST1 and the implementation language ST. So in order to call your instant of the timer, let's hit F2, go to the instance calls, and there's only one instance declared. Let's select that, hit OK. So TwinCAT pre-populates the function block instance that you have created. All you have to do is pass your application variables. So there's the in, which is our bprox. There's a time to pass, which is t hash 3 seconds. And then you can declare your output and the elapsed time if you want to record that into a variable. I'll do it a bit differently. We'll end this here. And we will say b break output is equal to our timer's output. If you hit the dot, it will show you all the outputs and inputs for that function. We can also just display the elapsed time without assigning it to anything. I'll put a comment here. This is for display. So as the program is executing, we will see what the elapsed time is. Let's go back to main, make sure we are calling our new function, or our new program rather. Same comment. And let's get started. Let's switch to the new program. Let's run the scope. And I'll trigger the proximity sensor once again. But first we need to start the program from running. As you can see, the timer is running, and after 3 seconds, output turns on. When the proximity sensor goes off, the output goes off. Next, we are going to explore the T-off timer, which I mentioned in the beginning is the off delay timer. So let's create an off delay timer. Let's log out first. I think we can use the same booleans and just create a new timer. This time I'm going to instantiate the timer first. We call it T-off break delay timer of type T-off. Next, we're going to go back to our structured text, and we will comment this section out and call our new T-off timer. So input in is equal to the proximity sensor, and we can end this here. Next, we will pass the time period dot. We can do it this way. So in the T on timer's case, in the first line, we instantiated all inputs. We passed all inputs in the same statement. Here, in the first statement, we are just passing the boolean, and everything else can be passed on like this. Now, the break output can be done the same way by assigning it to the timer's output. And I also want to see how much time is elapsed. So we can do it this way and not assign anything. We can say it for display. And there we have it. Let's download this into the PLC. Run the PLC. And let's start our recording for the measurement project. So as you can see, both inputs and outputs are switched off. Let's turn on the proximity sensor. The output comes on instantly. There is no on delay this time. This time we are doing the off delay. And the off delay is for 3 seconds. So after the proximity sensor goes off, the brake is going to turn off 3 seconds after that period has elapsed. So let's turn off the sensor out input. You can see it drop. And 3 seconds later, the output has dropped. So this timer is different from the on delay timer, where the output gets delayed by the specified amount after the input goes on. The off delay is the exact opposite. The output goes off after the specified delay when the input goes off. Next, let's see the timer implementation in ladder logic. So we will comment out the ST1 program and get back to the LD1 program. I already have my timer declared from last time. So let's go to LD1. We don't need this. I'm going to comment it out, add a new rung, and this time let's do it from here. So you click the box button and we can just do a text search. This is the function block we want to add from the standard library. and we have already declared, so we will use our name, and there we have it. Again, our time to pass will be 3 seconds. We don't need this. And our input is the proximity sensor. Our output is the brake. And there we have it. Download the PLC and get it to run. PLC has been downloaded. Start. Both inputs and outputs are turned off. Now remember, this is the off delay timer. So my output is going to come on at the same time as the input. So as soon as the brake sensor, the proximity sensor comes on, output turns on. It's delaying the off function. So when the timer goes off or turns to false, the output is going to stay for the 3 seconds and then turn off. Lastly, we are going to explore the pulse generator, or the TP. Since we are in ladder, let's start with the ladder implementation first. So we can go back to the main program and declare the TP instance. So I'll call it TP brake pulse of type TP. So this is not a delay timer. This will generate an output pulse when the input is triggered. So let's go back to our ladder. We can comment this out, insert a new rung. I'm just showing different ways. We can start from here, give it the name that we just declared, and there we have it. Assign the output, assign the input, and how long of a pulse do we need? Let's say we need a pulse of 2 seconds. We are not assigning anything to the elapsed time, so let's just clear that. And there we have it. Let's download this to the PLC and run. Let's have our measurement scope running. I'm going to trigger the input. The output comes on and drops. If I align this here, we can see the pulse width is 2 seconds. Let's do the same thing in statement logic. So I'm going to log out, go to main, comment the ladder out, get back to our structured text. Let's comment this section out and start here with the TP implementation. I'm going to hit F2, go to instance calls, and there's my instance of TP. And there we have it. That's my input. Let's do it different here, T hash 5 seconds. And the output is brake output. And we don't need the rest of this. And there we have it. If we want, we can display it here, like I said, for display purposes only. And let's download and see how this works. Start, run our chart. I'm going to trigger the input. Proximity sensor comes on and the output becomes true. Timer is counting. 5 seconds later, boom, drops. So I hope you guys have learned about the three timers specified in the IEC 61131-3 standards and how to implement them in TwinCAT. If you have any questions, please feel free to comment. If you have any other requirements that you would like me to try in future videos, leave a comment below. Thanks.